Apple spent 5 years and billions of dollars developing memory integrity enforcement for their new M5 chip. It was built to be a hardware-level defense that simply couldn't be bypassed. In May 2026, it cracked in less than a week. This timeline shows the scale of the mismatch. Apple invested 5 years into this defense. A 3-person security team using an AI model called Mythos produced a working exploit in exactly 5 days. The exploit worked because of how the model generalizes. Once Mythos learned to identify this specific class of memory corruption, it could apply that logic to find similar weaknesses across entirely new hardware targets. The economic balance of security has shifted. When the time required to dismantle a defense is measured in days rather than years, the cost to build a system becomes significantly higher than the cost to break it. This imbalance isn't limited to hardware. We're seeing the same structural stress inside universities, where the ability to verify authentic learning is struggling to keep pace with AI-assisted output. Professors are reporting a widening gap in student performance. In one instance, a graduating senior aced every unproctored home-based assignment, but failed every proctored exam and quiz given in person. This flowchart illustrates the resulting pressure on the institution. Unverified learning leads to easier grading to maintain student evaluations. This keeps enrollment numbers steady, but it results in a cycle that produces graduates who haven't actually mastered the material. When an institution's verification methods fail, the college degree itself begins to lose its role as a reliable signal of skill in the professional world. In the enterprise sector, the competition has moved past raw reasoning scores. The market is now rewarding models that can integrate directly into specialized, high-value business workflows. This graph tracks a significant revenue shift. Anthropic's Claude reached $30 billion in annualized revenue this spring, moving past OpenAI's $25 billion. That growth is driven by deep enterprise adoption. 8 of the Fortune 10 companies are now paying for Claude subscriptions. The usage patterns explain the revenue gap. Claude is being used as a thinking partner for architectural work and coding, while ChatGPT maintains a lead in daily consumer traffic for general research and voice assistants. Commercial value is increasingly tied to a model's ability to execute these specialized, multi-step workflows, rather than just providing general information. Despite heavy investment, 93% of companies report that they lack the data infrastructure to make AI agents effective. They are spending millions on models without the specific information needed to drive results. Advertising giant Publicis recently spent $2.5 billion in cash to acquire LiveRamp, a company that manages identity data infrastructure. LiveRamp uses clean rooms, secure environments where companies can match customer data without exposing the raw personal details. It allows AI agents to know exactly who a customer is across different platforms. As frontier models become easier to access, proprietary data about individual identity has become the more valuable asset. The industry is beginning to challenge the idea that larger models with massive context windows are always better. When you feed an AI too much information at once, its attention often becomes diluted. This chart shows the performance of DeepSeek V4 as the input size grows. It performs well up to 150,000 tokens, but past the 300,000 token mark, it hits a 94% hallucination rate. Contrast that with Exabase's M1 system. They use Gemini 3 Flash, a much smaller, cheaper model, to achieve 96% accuracy on long-term memory tasks. Exabase succeeded by using a 3-phase retrieval pipeline instead of just expanding the context window. They built a system that finds the right information, rather than trying to remember all of it. This suggests for memory-heavy tasks, the design of the retrieval architecture is starting to matter as much as the parameter count of the model itself. There is also a massive price gap between frontier models, which cost $5 per million tokens, and open-weight models that cost only a few cents for the same volume. On specialized code repair benchmarks, the cheapest OpenAI model, GPT 5.4 Nano, achieved a baseline score of 67%. This bar chart shows how the committee voting method closes that gap. By running that cheap 20-cent model 8 times and using a verifier to pick the best result, it reached 76%, matching the performance of the most expensive models on the market. If developers can use verification to get frontier-level results from cheap models, the competitive advantage of proprietary models becomes much harder to maintain. Frequent AI users are running into context rot. This happens when irrelevant information from earlier in a chat session lingers, slowly degrading the quality of the AI's current responses. This has led to the discipline of context engineering. The goal is to curate the smallest possible set of high-quality information for the model to work with at any given time. New tools now allow users to selectively compress or isolate data within a session. Instead of the AI looking at everything you've said, it focuses only on the specific facts required for the current task. As models become more capable, the primary skill for the user is shifting. Success is becoming less about writing the right prompt and more about managing the information the model consumes. There is a secondary effect to this efficiency. As different models train on the same optimized datasets, they are beginning to produce nearly identical results. 8 different frontier models were recently asked to invent a name for a lighthouse keeper. Every one of them independently chose the name Elias Thorne. We are seeing this specific naming pattern appear in problematic ways. This AI-generated cancer treatment handbook, which reached the top 20 in its category on Amazon, was published under that same Elias Thorne name. In an era where intelligence is becoming a commodity, the value is no longer in the model itself. It is found in the architecture, the data, and the curation used to make that intelligence accurate and distinct.